And our objectives: to be able to solve quadratic equations by 1. Extracting the roots, number 2. Factoring, number 3. Completing the square, and number 4. Using the quadratic formula. And now, before we would proceed on discussing those objectives, let us first be reviewed about what is the standard form of quadratic equations. Okay, so the standard form of quadratic equations is ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers. Okay, so this is the standard form. Ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers, and a must not be equal to 0. A is the numerical coefficient of the first term, b is the numerical coefficient of the second term, and c is the constant. So I do suggest have a review on your grade 8 topic on how to transform quadratic equations into standard form. It is because if you do the factoring, the completing the square, and the using quadratic formula, the quadratic equation must be on its standard form so that you could proceed, okay, on solving this quadratic equation. Okay, and I guess that would be all. So now let's proceed to our first one, the extracting the roots. Okay, extracting the roots. So if you could remember, extracting the roots, this was discussed when you were grade 8, but that was not solving quadratic equations. That was just factoring by extracting the roots. And right now, I guess extracting the root, this was difference of two squares. It's somewhat similar to factoring difference of two squares. Okay, so on extracting the roots, the equation must be on the form of x squared is equal to k. So when would we use extracting the root? Okay, so I guess extracting the root would be most appropriate when the quadratic equation has only two terms. Okay, when it has only two terms and those two terms are perfect squares. So if those two terms are perfect squares, then I guess extracting the root is the most appropriate one. But if the k here is not a perfect square, you may also still apply extracting the roots. Okay, and we have few things to be reminded when we are doing extracting the roots. So few things to be reminded. If okay so if k here is greater than 0, then x squared is equal to k has two real solutions or roots. Okay, so you would see if k here is greater than 0, then two solutions would be the positive and the negative of the root of k. And number 2, if k is equal to 0, then x squared is equal to k has one real solution or root. X is equal to 0, only one, and it's x is equal to 0. And if k is less than 0, then x squared equals to k has no real solutions or roots. Meaning, if k here is less than 0, let's say the negatives. So therefore, if k is less than 0, then it has no real solutions or no real roots. So now let's have an example. Okay, let's have an example on how to do the extracting the roots. Okay, let's have the first example. Say x squared is equal to 36. Okay, this is our first example. X squared is equal to 36. So now, the first thing that we need to do is, of course, apply the properties on the radical, wherein we would, to make it short, we would extract the root of both terms that we have on the x squared on the 36. So meaning it would become like this. So we would apply, okay, we would extract the root. So we would have the square root. Okay, we have the square root of x squared is equal to the square root of 36. So this is what we would do. We would extract the root. That is why it is called extracting the root. And then, Okay, a square root of x squared, that would be equal to x, right? The square root of x squared, that would be equal to x, is equal to, what's the square root of 36? The square root of 36 is 6, right? But since we all know that if k is greater than 0, then it has two real roots, the positive and the negative of that root. So therefore, square root of 36 is equal to 6, and it would be not only 6, it's because it would be, okay, it would be the positive and negative of 6. Okay, so it's because why positive and negative? It's because if we would do the math, we say 6 times 6, that is equal to 36, and negative 6 times negative 6, it is still equal to 36. So therefore, the square root of 36 is positive and negative 6. So therefore, we would say the roots of this quadratic equation would be, okay, equal to 6, and the other one would be to negative 6. Okay, and these are the roots. X is equal to 6 and x is equal to negative 6. Okay, so let's have another example. Okay, another example. Let us say we would have this one. What if it would look like this? 2x squared is equal to 72. Now, as we all know, on this type of quadratic equation, we could say there are only two terms, right? The first term is 2x squared, and the second one is 72. And here, as you could see, we have a numerical coefficient of 2. Okay, our numerical coefficient here is 2. So now, before we would proceed to extracting the root, we must convert it first to like this, wherein its numerical coefficient is equal to 1. So now, in this case, we must apply first properties of equality. On this case, we would apply division property of equality so that our numerical coefficient 2 here would be equal to 1. So now, let's apply division property of inequality, and let's divide both sides of the equation by the numerical coefficient, which is 2. So let's divide both sides. That would be, okay, that would be look like this. And then both sides would be divided by 2. Okay, so 2x squared divided by 2 is equal to 72 divided by 2. So that would be 2x squared divided by 2. That would be x squared is equal to 72 divided by 2. That would be equal to 36. Okay. And as you could see, it's the same with our example number 1. And then let's have it. Let's extract the root of x squared. That would be, what's the square root of x squared? And we would have the square root of 36. So square root of x squared is equal to the square root of 36, and the square root of x squared would be x, and then that would be equal to square root of 36. That would be positive negative 6. Okay, and our solution, we have two solutions. That is the first x, okay, the first x is equal to 6. Okay, so, and the second one is equal to negative 6. Okay, so that would be for our second example. Okay, so if we would see a quadratic, or rather than if we would see a quadratic equation whose numerical coefficient is not equal to 1, then we would apply division property of equality. Okay, if we are doing the extracting of the roots and its numerical coefficient of this term, of the first term, or the term with the variable and the exponent in the second degree is not equal to 1, then therefore let's apply division property of equality. Okay, so let's have another example. I guess this would be the last example for our extracting the root. So what if our quadratic equation would look like this? So x minus 2, then it is a group. Okay, it is a group that is on the second degree. So we have x, the group x minus 2 raised to the second power. So the quantity of x minus 2 raised to the second power is equal to, let us say, 100. Okay, like that. This is our second example. By the way, if our quadratic equation is not on the x squared minus x squared equal to k form, then we would transform it into x squared equal to k form. Okay, so let's have another example. By the way, let's not have that number 3. The quantity of x minus 2, okay, square minus, let's say, minus 100 is equal to 0. Let's say like that. Okay, x squared, or the quantity of x minus 2 square minus 100 is equal to 0. As you can see, this is not on the form x squared equal to k. So that is why before we would apply the extracting the root, we must first transform it into x squared equal to k form. So therefore, it would look like this. Basically, we would apply addition property of equality, wherein we would add both sides of the equation by 100 so that it would become x squared equals to k form. So it would look like this. The quantity of x minus 2 square is equal to 100. What did we do? We applied addition property of equality, wherein we added 100 on both sides of the equation. Okay, we added 100 here, plus 100 here, and plus 100 on the other side of the equation, so that it would become the quantity of x minus 2 square is equal to 100. And then afterwards, you may now apply, okay, if it is already on the x square is equal to k form, you may now apply extracting the root. So we would extract the root, the square root of the quantity of, okay, x minus 2 square is equal to the square root of 100. Okay, so let's extract the roots, and then it would become, what's the square root of x, the quantity of x minus 2 square? And that would be simply the quantity of x minus 2. Then it would be x minus 2 equal to, what is the square root of 100? That is positive and negative 10, right? We have two solutions on that, so that would be positive, negative 10. Now, what are our solutions? As we could see, we have the quantity of x minus 2 is equal to the positive and negative 10. And let's have our first solution. Okay, our first solution is equal to, okay, it's minus 2 is equal to, let's say, let's use the positive first, is equal to positive 10. And then before we would have our final solution, let's apply addition property of equality, and it would be equal to, let's say, 10 plus 2. And our first solution would be 10 plus 2, that would be 12. Okay, that would be our first solution. First x sub 1 is equal to 12. And for the second solution, okay, for the second solution, so it would be x sub 2 minus 2 is equal to negative 10. Now let's use negative 10. Okay, so it would become x sub 2 is equal to negative 10 plus 2. Let us apply, okay, let us apply what we call the addition property of equality, wherein we add 2 on both sides of the equation. And our second solution is equal to negative 10 plus 2, that is negative 8. Okay, so I guess that is it. We have two solutions for our example number 3. Our example number 3, the quantity of x minus 2 square minus 100 is equal to 0. First, we transform it into x squared equal to k form, and then afterwards we extracted the root, and then extracting them, we have two solutions. Our first x is equal to 12, and our second x is equal to negative 8. Okay, so I guess that would be all for the extracting the roots. And now let's proceed to factoring. Okay, let's proceed to factoring. there are many kinds of factoring that we have. So we have the common monomial factoring, we have the difference of two squares, we have the sum and difference of two cubes, we have perfect square trinomials, we have the general trinomial, and we have the AC method. Okay, so if you forgot about them, I have another video that is a grade 8 topic, and it talks about factoring. Okay, so now let us continue on solving quadratic equations by factoring. Okay, so now let's have our first example. Okay, and our first example would be, okay, our first example would be a perfect square trinomial. Okay, our first, okay, perfect square trinomial. So let's have x squared plus 10x plus 25 is equal to 0. Now, this is a perfect square trinomial. It's because the first term is a perfect square, the third term or the last term is a perfect square, and the second term is the twice of the root of the third term. You see, square root of 25, that is 5 times 2, that is 10. Okay, so therefore, this example is a perfect square trinomial. Now, how to solve this quadratic equation using factoring. Okay, the first that we would apply is our background regarding with the factoring. That is why we would find for the factors of this. Okay, let's find the factors of x squared plus 10x plus 25, and that would be, since this is a perfect square trinomial, that is x plus 5, the quantity of x plus 5 times the quantity of x plus 5 is equal to 0. Okay, so these are the factored form. We have the quantity of x plus 5 plus the quantity of x plus 5. And the next step that we would do is that we would apply zero product property. Okay, that's very important. What would we apply? We would apply the zero product property. Okay, so what is zero product property? Okay, zero product property is the process wherein both factors would be equated to 0. Okay, both factors would be equated to 0, meaning the quantity of x plus 5, that would be x plus 5 equals 0. Okay, and that is zero product property. Okay, so now let's have the first one. Plus 5 is equal to 0. Okay, so this is the first factor. So x, we have the x sub 1, our first factor. We have the x sub 1 plus 5 is equal to 0. And let's have our next factor. Let's, for a moment. Okay, so let's have our next factor. That would be x. We have x sub 2 plus 5 is equal to 0. Okay, then again, when we say zero product property, it means we would equate both factors to 0. Okay, as easy as that. So the next step is we would apply properties of equality that are present or applicable. On this case, on our first factor, that is, we would apply subtraction property of equality. So we would subtract 5 on both sides of the equation, and then if we would subtract 5 on both sides of the equation, so that would become x sub 1 plus 5 minus 5, that would be 0, is equal to 0 minus 5, that would be negative 5. Okay, and let's have our second root. We have x plus x sub 2 plus 5 minus 5, that would be equal to 0, and 0 minus 5, that would be equal to negative 5. So therefore our root or our solution on our first example, x squared plus 10x plus 5 is equal to 0. The roots are negative 5 and negative 5. So take note, if your quadratic equation is a perfect square trinomial, that would be always the roots are equal. Okay, they are the same if it is a perfect square trinomial. In this case, x squared plus 10x plus 25 equals 0, and then the roots are -5 and -5. It's the same. As long as it is a perfect square trinomial, their roots are the same. Okay, so now let's proceed to our second example. Okay, right now our second example would be a general trinomial. Okay, let's practice a general trinomial. Let's say we have x squared x squared plus, let's say, 7x plus 10 is equal to 0. Okay, so we have x squared plus 7x plus 10 is equal to 0. Now this is an example. Okay, this is an example of a general trinomial. Okay, as you could see, the first term, yes, it is a perfect square trinomial, but the last term or the third term is not a perfect square trinomial. That is why it is classified as a general trinomial. And the next step that we would do is to factor it out. Okay, so factoring general trinomials. So how to factor out general trinomials? We would think of numbers. We would think of numbers that are, okay, numbers that are, if we would multiply, equal to 10, and then if we would add, equal to 7. Okay, so what are the factors of 10? Factors of 10 that if we would add, they are equal to 7. So let's think for a while. So what are the numbers that if we would multiply, that would be equal to 10, and if we would add, equal to 7, and that would be 5, and that would be 2. Okay, so let's check. So 5 times 2, it's 10, and 5 plus 2, it is 7. So therefore, the factors are the quantity of x plus 5 and the quantity of x plus 2. And the next step that we would apply, the same with the first one, we would apply what we call the zero product property. Okay, when we say zero product property, we would, okay, what's zero product property? We would equate both of the factors to 0. Okay, technically, when we say zero product property, it's like AB equals to 0, therefore A equals to 0 and B equals to 0. Okay, in short words, when you say zero product property, both factors would be equated to 0, as easy as that. Okay, so now let us proceed. So now our first factor, okay, we have x sub 1 plus 5 is equal to 0. Okay, because we would equate it to 0. And then we have x sub 2 plus 5, or rather plus 2 is equal to 0. Okay, and then the next step that we would do is the same with our first example. Okay, the same with our first example, we would apply properties of equality. On this case, we would apply subtraction property of equality, wherein we would subtract the constant on both sides of the equation so that we could isolate the variable and the constant. So it would become like this. So plus 5 minus 5 equals 0 minus 5. That would be equals to -5. And then in the second one, we have x sub 2 is equal to, okay, so we have x sub 2 plus 2 minus 2, that's 0, and 0 minus 2, that's -2. Okay, so this is our solutions. These are our roots, our solution set. So therefore, okay, if we would compare, if we have a perfect square trinomial, our roots are equal, they are the same. But if we have a general trinomial, our roots are, yes, they are real numbers, but they are not equal. And now let us proceed to our third objective, the completing the square. Completing this square. Okay, now when to use completing the square? Okay, when to use completing the square? In my opinion, the general trinomial and completing the square are almost the same, but for me, I would use completing the square if, for example, I do not know the factors of that certain general trinomial. Okay, for example, there is a quadratic equation to be solved, and that quadratic equation is in a general trinomial form. And then in that general trinomial, I really don't know what are the factors, and if I do not know the factors, it would consume much of our time thinking what are the factors of this general trinomial. Instead, we could proceed doing the completing the square. Okay, that is a lifesaver if we could not think about the factors of that general trinomial. Let's do it using the completing the square. So for example, we have, let's have our first example. We have the x squared plus 8x, let's say minus plus 8x minus 9 is equal to 0. For example, this one, x squared plus 8x minus 9 is equal to 0. For example, this is a general trinomial, right? And on this sense, for example, I do not know what are the factors of negative 9 that if we would add, that would be equal to positive 8. That is why I do not know the factors, and then I would do completing the square. Okay, so how or what are the steps in doing completing the square? So the first step is the constant must be on the other side of the equation. So it would look like this: x squared plus 8x is equal to positive 9. So now, as you could see, the constant is in the other side of the equation. So from negative 9, we applied addition property of equality. So then again, it became x squared plus 8x minus 9 plus 9. It's 0 equals 0 plus 9. That's why it's positive 9. And then the next one is, as you could see, we have x squared plus 8x. X squared plus 8x. These two terms, we would add another term for the constant so that it would become a perfect square trinomial. Okay? From the two terms, x squared plus 8x, we would add another term. Okay? We would add another term so that it would become a perfect square trinomial. So we would have x squared plus 8x. So now, what would be the term? Okay, that's the question now. What would be the term that we would add so that it would become a perfect square trinomial? So we have steps for it to identify, and the steps would be like this. Look at the second term. We have 8, right? We have 8. So that 8, let's divide it by 2. So 8 divide 2, that is 4. Again, the second term, divide it by 2. So 8 divide 2, that's 4, and have it square. And what is 4 square? That is 16. Okay? So where did we get 16? We get 16 from the second term. Okay? The second term. The second term to be divided by 2. 8 divide 2, that's 4. And get the square. 4 square, that's 4 times 4. And 16. Okay? So now we have 16 is equal to 9. And then we would add. Okay? No matter what number you added from the other side of the equation, you would also add it to the other side of the equation. Okay, so since we added 16, we would also add 16 here. Okay, since we added 16 so that it would become a perfect square trinomial, we would also add, okay, we would also add 16 on the other side of the equation. Okay, and then afterwards, it is now a perfect square trinomial, and let's get its factors. So that would be the quantity of x plus 4 times the quantity of x plus 4. Okay, x plus 4, because it is a perfect square trinomial. So in order for us to factor it out, let us just get the root of the first term and the root of the last term and do it twice. So that's the quantity of x plus 4 times the quantity of x plus 4, and then we would add 9 plus 16, that's 25. Okay, that's 25. And then, as you could see, the quantity of x plus 4 times the quantity of x plus 4, that is just the same with the quantity of x plus 4 square, right? So that's just the same. Okay, let's have it. And then equal to 25. And then we are now on this form. Are you familiar with this form? Are you familiar? This is the form x squared is equal to k, right? X squared is equal to k. Can you remember this form? And then it's because we are in this form, you would apply extracting the root. Okay? So from completing the square, the process, we would also have it as on the process of the completing the square after having the perfect square trinomial and then adding them, having it as a square, and this is a square, 25 is a perfect square, and then you would apply perfect square trinomial. So that would be the square root of the quantity of x plus 4 square is equal to the square root of 25. Okay? And then, so what's the square root of the quantity of x plus 4 square? That would be simply, okay, that would be simply x plus 4, right? You would cancel out the square and the square root, the exponent and the radical sign. That would be equal to, could you remember? Equal to, what are the roots? That's positive, negative 5. Okay, that would be positive and negative 5. And let's continue. The process is the same with completing the square. So let's draw a line first. Okay, let's continue. So our that one. So our first one would be x sub 1 plus 4 is equal to positive 5. And then for the second one, we have x sub 2, or rather x sub 2 is plus 4 is equal to negative 5. And then the next step is we would apply properties of equality. On this case, we would apply subtraction property of equality. That would become x sub 1 is equal to, let's say, 4 minus 4, that's 0, and 5 minus 4, that's equal to 1. Okay, and on the next one, we have x sub 2, that's 4 plus 4, that would be equal to 0, and we have negative 5 minus 4, rather than 4 minus 4, that's equals to 0, and negative 5 minus 4, that's negative 9. Okay, so now here are our roots. We have the first root, which is equal to 1, and the second root is equal to negative 1 using completing the square. So we have the solving quadratic equation using completing the square. Okay, now let's have another example. On this example, this would be quite difficult. I want you to pay attention. On our second example, let's have it here in the center. We have 2x square plus 7x minus 5 is equal to 0. Okay, this is our second example. Now, as you can see, why would we apply completing this square on this kind of quadratic equation? Okay, in my opinion, first is it's really difficult for us to find for the factors. Okay, so if there are factors on this one, the factors are not whole numbers. If the factors are not whole numbers, it could be only solved by two ways. First one is completing the square, and the second way is using the quadratic formula. Again, if the factors or the roots of your quadratic equation, are not real numbers, the only way for us to solve it, or the two ways, there are also other ways, but the two ways that I would suggest are only completing the square and using the quadratic formula. Okay, let's try this one using completing the square, and later on let's use this example also on the quadratic formula. Okay, so now let's continue. The process is the same. The constant would be transferred to the other side of the equation, so it would look like this: 2x square plus 7x plus 7x is equal to 5. Okay, so as you could see, as you can see, our numerical coefficient on the first term, look at this one, our numerical coefficient on the first term is not equal to 1. So it should be equal to 1. That is why we would apply properties, another properties of equality, and on this case, we would apply the division property of equality, wherein we would divide both sides of the equation by the numerical coefficient of the first term. Or for short, we would divide them all of the terms, and as well as on the other side of the equation by our numerical coefficient, and our numerical coefficient is 2. Okay, that is 2. So therefore, it would become, and it would look like this. So it would be 2x squared divided 2, that would be x squared, plus that would be 7x over 2. So later on, let's have the 7x over 2 is equal to 5 over 2. Okay, so it's quite difficult in this case because I'm using the paint. So let me do it this way. So 7x over 2, and then we have the 5x over 2. Okay, so now this is now where we could apply the completing the square. Now you see, we have two terms. We have the x squared plus 7x over 2. These two terms, we would complete these two terms. We would add another term so that it would become a perfect square trinomial. So what would be the term that we would add? So the process is the same on our first example. So we would add it by the, we would add the what? What would we add? We would add the second term would be divided into 2. So we could have 7x over 2 divide 2. What is 7x over 2 divide 2? That would become, if you could remember, that is, what would be the process? If you would divide, you would multiply it by the reciprocal, right? So 7x over 2 divide 2, that is just the same as 7x over 2 times, that would be what? To be multiplied by 1/2, right? That would be multiplied by 1/2. So therefore, it would become, if we would multiply it to 1/2, it would become 7 over 4. 7 over 4, and let's have the square of 7 over 4, and that would be 49 over 16. So that would become, let's have it, plus 7x over 2, plus 49 is equal to 5 plus 49. Okay, so let's have the 49 in this case. Let's have it over okay, so that would be I would really appreciate if you could suggest any ways for me to make this easier. If I could have it on Word, but I guess Paint is much accessible, or rather than what you call that, easy for me to have. So this would be 2, and this would be 16, this would be 2, this would be 16. Okay, so let's continue. This is now a perfect square trinomial, and whatever we added on this side of the equation, we would also add it on the other side of the equation. So let's continue. This is now a perfect square trinomial. As you can see, x squared plus 7x over 2 plus 49 over 16. That is now a perfect square trinomial. The first term is a perfect square. The last term is a perfect square. And if you would check, this would be, if you would check, you would get the root of the last term. What's the root of the last term? That would be 7 over 4. And then if you would if you would divide it by 2, 7 over 4 divided by 2, that would be 7 over 2. Okay, so this is now a perfect square trinomial, and 5 over 2 plus 49 over 16 would be added afterwards. Okay, so now let's continue. This would become, since this is now a perfect square trinomial, this would become the quantity of x plus, what's the square root of 49 over 16? You would treat it 1 by 1. It would be 7 over 4, right? That would be 7 over 4. So we could have the quantity of x plus 7 over 4. Let's have the 4 later on. And the quantity of x plus 7 over 4, okay, is equal to, okay, is equal to, so we would add this two. We would add 5 over 2 plus 49 over 16. So the LCD would be 16, okay? The LCD would be 16, and then we would have 16 divide 2, that would be 8 times 4. 8 times 4 rather. 16 divide 2, that's 8 times 5, that is equal to 40. And then 16 divide 16, that's 1. Then divide multiplied by 49, that's 49. So 40 plus 49, that is equal to 89 over 16. Okay, so let's have this. What you call that? That is 7 over 4, 7 over 4, and then and this is, in a moment, and this is 89 over 16. So let's have it. Okay, 7 over 4, and then we have 7 over 4, and then 89 over 16. Okay, and the next one is, since this is the quantity of x plus 7 over 4 times the quantity of x plus 7 over 4, we could have it, we could merge it as the square of a binomial. So it would become, let's say, the quantity of x plus 7 square, x plus 7 over 4 square is equal to 89 over 16. Okay, 89 over 16. So let's have the over. Okay, in a moment. Okay, so that would be this would be 4, and we have 16. Okay, and now as you can see, this is now on the form of x squared is equal to k. X squared is equal to k. So at this point, you may now apply extracting the root. Okay, let's now apply extracting the root. The process is the same with our first example as well as the examples on extracting the root. So this would become the square root of the quantity of x plus 7 over 4 square. So the quantity of x plus 7 over 4 square is equal to the square root of 89 over 16. So equal to the square root of 89 over 16. So let's have the over. This is over 4. And this is over 4. Okay, so that would become over 4 over 4 over 4 and over 16 rather. Okay, now, and the next step is, let's follow through. This would become, we would cancel out the radical sign in the exponent, so it would just become the quantity of x plus 7 over 4. Okay, we canceled out the radical sign, the square root, and the second degree is equal to, that's the square root of 89 over 16. Please bear with me. This should be, the square root here should be to all. Okay, okay, so let's have it like this so that I would not be corrected. Let's have it like this. Okay, in a moment. Outline, no outline. Okay, so so let's draw. Okay, so that it would be really correct. Outline, solid. Okay, let's draw. Okay, that should be like that. Okay, so outline, no. Okay, let's continue. So this would be like this. Okay. Okay, so that would be My bad. Okay, so this would be over 16 and this would be over 4. Okay, so this would be over 4 and over 16. Okay, and let's draw the square root. Okay, I have a technique. Let's do it like this. Okay, in a moment, guys, in a moment. Okay, let's have this, and then let's select this one. Oh, not yet, not yet. Okay, as easy as that. Okay, now let's continue. Okay. That should be like that. Okay, very good. Okay, let's continue. That would be 89 over 16. Okay, that would suffice. I guess that's better. Okay, now as you can see, the quantity of I'm bothered by this one. So the quantity of x plus 7 over 4 is equal to the square root of 89 over 16. And I guess this would be the final answer. This would be the final answer. And then let's continue this one. Not yet the final answer, but almost rather. So let's continue. So it would become, okay, x sub 1 x sub 1 is equal to we would apply subtraction property of equality, wherein we would subtract, okay, we would subtract 7 over 4 on both sides of the equation. So the quantity of, or let's say the quantity of x plus 7 over 4 minus 7 over 4, that would be equal to 0, is equal to the negative, okay, we have negative 7 over 4, and then negative 7 over 4, then you would have the plus minus, let's have the positive first. Let's have the positive first. So the positive, and then 89. Okay, let's have the positive 89 over 16. Let's have, okay, bear with me, I'm very sorry for this. With positive 89. Okay, we have 89 over 16. 89 over 16. This is for the first root, and for the second we would have x sub 2 is equal to negative 7 over 4. Oh my, I forgot the over 4. 7 over 4. Since we had the plus here right now, let's have the minus. Okay, the minus 89 over 16. Okay, let's have this minus 89 over 16. Okay, so let's have this 89 over 16, and we forgot the 4 here. Okay, mind, let's have this one. I forgot this. And that's it. Okay, that's it. So this is our first solution, or rather first root, and this is our second root. Okay, so this is not a whole number, that is why we stick with this one. But if you wanted it to have the exact one, you may use your calculators. Okay, so our first root is x sub 1 is equal to negative 7 over 4 plus the square root of 89 over 16, and we also have x sub 2 is equal to negative 7 over 4 minus 89 over 16. Now take note, you can still simplify this one. If we would simplify this one, that would be equal to square root of 89 over 4, or let's have this square root of 89 over 4, or the square root of 89. Let's have the second one, the simpler form. Never mind. Okay, so we can simplify this one further. As you can see, this would become square root of 89 over 4, and this one would also become square root of 89 over 4. And as you could see, negative 7 over 4 plus square root of 89 over 4, the LCD, they are the same, so that would be 4. As well as with this one, negative 7 over 4 minus square root of 89 over 4, the LCD would be also equal to 4, so it would become like this. Okay, so this is the simplest form. And of course, if you wanted to know the exact value, you may use your calculator. Okay, so now let's continue to our fourth objective, solving quadratic equations by using the quadratic formula. Okay, the fourth one is by using the quadratic formula. Okay, before anything else, let me discuss to you the pros and cons of using the quadratic formula. Okay, now the cons here is, of course, you need to remember, you need to memorize the quadratic formula. The problem here is if you cannot remember or you cannot memorize the quadratic formula, therefore you cannot use the quadratic formula, right? That's the very disadvantage of using the quadratic formula. If you do not know it, then you cannot use the quadratic formula. And what is the pros? What is the advantage of knowing quadratic formula? The very advantage of knowing quadratic formula is that it is applicable to all quadratic equation. Okay, it is applicable to all. Okay, so that's because there are cases like, for example, there are quadratic equations that you cannot use factoring. For example, whose roots are not whole numbers, you cannot simply use factoring. For example, the extracting the roots, you cannot use extracting the roots if there are three terms, right? For example, in a perfect square trinomial, you cannot directly use extracting the root, and there would be have difficulties on which of which you would use. Whereas if you know the quadratic formula, you can use it to all of the quadratic equations. Okay, and for me, the process would be long. But if you mastered quadratic formula, then therefore you would definitely arrive at the correct answer. Okay, now let's start. Let's use our example, the same example of what we had here on the completing the square. This one, the same example. So let's have 2x squared. So let's write example, by the way. Okay, let's have an example. Let's only have one example for this one because our video is almost an hour, so it's very long right now. So let's have one example for this. So we have 2x squared plus 7x minus 5 is equal to 0. Okay. And then let us use the quadratic formula. Okay, now what are this? A, B, C. By the way, quadratic formula, that is x is equal to negative b plus minus square root of b squared minus 4ac over 2a. By the way, that is our quadratic formula right now, and that would be the one that we would use, okay? So if you wanted to use quadratic formula, I do suggest memorize this one, okay? So that would be, so b here, b, let's be acquainted of this one first. B is the numerical coefficient of the second term, a is the numerical coefficient of the first term, and c is the constant, okay? So let's continue. That would be equal to negative b, so that would be negative 7. Let's only deal with the numerical coefficients, okay? Then plus minus the square root of, okay, that would be applicable to all, b squared. What's b squared? So let's write it first. 7. Okay, 7. What happened? Okay, 7 square minus 4 times a. What's a? We have 2. And what is c? We have negative 5. Okay, 2. Then we have negative 5. Okay, over 2a. So over, so let's have this. Let's draw it again one more time. Okay, that should be like that. Okay, and over, all over 2a. Okay, 2a is, that's 2, and a here is 2, right? A is 2. Okay, that would be like that. And then let's continue. By the way, let's continue it right here. Okay, let's continue it right here. Okay, let's continue it right here. Okay, so that we have enough space. So this would become, let's apply the indicated operation. That would be equal to negative 7, there's negative of b, plus minus the square root of, what is 7 square? 7 square is 49, minus, okay, minus, let's have this as, let's treat it one by one. Negative 5 times 2, that would be 10, times negative 4, that would be positive 40. So instead of having it as minus negative 40, we could directly have it as plus, okay, plus 40. Okay, by the way, let me repeat it again. Negative 5 times 2, that's negative 10, times 4, that's negative 40. Instead of writing negative, or rather 49 minus negative 40, you can directly write it as plus 40, okay? So that it would be easier on your part. Let's say minus negative, it is just the same with adding, okay? 5 minus negative 5, that is the same as 5 plus 5. So 49 minus negative 40, it is the same with 49 plus 40, okay? So let's continue. So that would be like that, okay? And then okay, and then afterwards 2a, 2 times 2, what's 2 times 2? That's 4, right? That's 4. And then afterwards we would have, okay, we would have equal to negative 7 plus minus, that's square root of 49 plus 40, that's 89, right? That's 89, and then over 4. Over 4. And I guess we have our final answer now. As you can see, this is the same with this one, right? As you can see, they are the same. So let's just select this one to minimize our effort. So these are our answer now. Okay, so our first root is negative 7 plus square root of 89 over 4, and our second root is negative 7 minus square root of 89 over 4. Okay, I guess that would be all. And as you could notice, quadratic equation, it's much shorter than this completing the square, right? Using the quadratic formula, it is much shorter then using this completing the square. Okay, but they arrive with the same answer. Okay, so I guess that would be all, and thank you for listening, and God bless. So don't forget to like and subscribe my channel, and so that you would be notified for further videos next week. Thank you.